A fisherman along India's western coast now reads the sea like a warning sign, not a livelihood map. The catch is unpredictable, waters feel warmer, and coral beds are fading. Simultaneously, in northwest India, regions once synonymous with aridity are witnessing intense erratic rainfall. These are not isolated anomalies, they are signals of a deeper systemic crisis. The State of India's Environment 2026 report confirms that India has breached 7 out of 9 planetary boundaries, with ocean acidification emerging as the latest red line crossed. This moment marks not just environmental stress but a phase of regional boiling where climate impacts intensify unevenly across geographies. The concept of planetary boundaries rooted in Earth system science defines safe ecological limits with which humanity can operate. Crossing these thresholds, such as climate change, biodiversity, and now ocean acidification, risks destabilizing Earth's life support systems. India breaching 7 of these boundaries indicates that environmental degradation is no longer incremental, it is systemic and accelerating. Ocean acidification, the seventh breached boundary, exemplifies this crisis. Increased atmospheric carbon dioxide dissolves into oceans, forming carbonic acid and reducing pH levels. The reported 30 to 40% rise in acidity disrupts marine ecosystems, particularly calcifying organisms like corals and shellfish. For India, this has direct economic and social consequences. Coastal communities dependent on fisheries face declining yields while marine biodiversity loss threatens ecological balance. The rise in marine heat waves, that is, the prolonged periods of abnormally warm ocean temperatures, further compounds this stress. These heat waves reduce oxygen levels, trigger coral bleaching, and alter fish migration patterns, creating uncertainty in food security. Parallelly, India's land systems are witnessing paradoxical shifts. The wet desert paradox in northwest India highlights increasing rainfall in traditionally dry regions such as Rajasthan. At first glance, this appears beneficial. However, it reflects disrupted monsoonal patterns driven by warming oceans and atmospheric instability. Such rainfall is often intense and short lived, leading to flash floods rather than sustainable water availability. This shift challenges traditional agricultural practices and water management systems, underscoring the need for adaptive planning. These developments must be understood through the lens of geography. India's climatic systems, that is, the monsoons, ocean currents, and land atmosphere interactions, are undergoing structural changes. Warming in the Indian Ocean, particularly the Arabian Sea, is intensifying cyclonic activity and altering rainfall distribution. Spatial heterogeneity in climate impacts means that vulnerability is region specific, requiring decentralized and context sensitive responses. From an environment perspective, the phenomena of compound extremes is particularly alarming. These occur when multiple climate stressors such as heat waves and droughts interact simultaneously, amplifying their impact. For example, a region experiencing both extreme heat and water scarcity faces compounded risks to agriculture, health, and livelihoods. Such events strain governance systems, as traditional disaster management frameworks are often designed to address single hazards. India's policy response, while evolving, must now match the scale and complexity of the crisis. Initiatives such as the National Action Plan on Climate Change and state level climate action plans provide a framework, but implementation gaps persist. There is a need to integrate climate resilience into sectoral policies like agriculture, fisheries, urban planning, rather than treating it as a standalone issue. In coastal regions, adaptive fisheries management is crucial. This includes real time monitoring of marine conditions, diversification of livelihoods, and investment in sustainable aquaculture. For regions experiencing the wet desert paradox, water management strategies must shift from scarcity focused to variability focused approaches, emphasizing storage, flood control, and efficient irrigation. Technological interventions such as early warning systems for marine heat waves and improved climate modeling can enhance preparedness. However, technology alone is insufficient without institutional coordination and community participation. Local knowledge systems, often overlooked, can provide valuable insights into coping mechanisms and resilience strategies. At a broader level, India's developmental trajectory must reconcile economic growth with ecological sustainability. The breach of planetary boundaries is a reminder that environmental costs cannot be externalized indefinitely. Policies must intensify sustainable practices, from renewable energy adoption to conversion of ecosystems such as mangroves and wetlands, which act as a natural buffers against climate impacts. The narrative of regional boiling challenges the notion of uniform climate change. It reveals a mosaic of impacts like warming seas, shifting rains, intensifying extremes, each demanding tailored responses. For policymakers, this means beyond one size fits all solutions to embrace adaptive region specific strategies. Ultimately, the SOE 2026 report is not merely a diagnostic document, it is a call to action. India stands at a critical juncture where environmental thresholds are being crossed with increasing frequency. The choice is stark: continue along a path of reactive responses or transition to proactive, resilience driven governance. The fisherman's uncertainty and the desert's unexpected rains are not disconnected stories. They are chapters of the same unfolding narrative, one where the boundaries of nature are being tested. Recognizing this interconnectedness is the first step towards crafting solutions that are not only effective but enduring.